Hello everyone, my name is Danijela Vrzan. Welcome to iOS Conference Singapore 2022 edition. My talk today will be about yet another Swift architecture called VIP. Now, I'm talking about this architecture because it's one of the least known architectures and you may have not heard about it, or you may have. So I'd like to introduce its concepts to you. Before we start, I'd like to tell you a little bit about myself. I'm a Croatian in Canada. I moved from Croatia to Toronto, Canada about 2.5 years ago. I work as an iOS developer on the front-end engineering team at Deloitte Digital Canada, and I write iOS articles for Ray Vanderlecht. Now, what exactly is VIP? Now, I assure you it does not stand for a very important architecture. As I already mentioned, it's one of the least known architectural patterns in iOS development compared to MVVM, MVC, or VIPER. You mostly heard about those. When I talk with people and tell them I'm using VIP architectural pattern on the current project at my work, they say, "Oh yeah, I've heard about VIPER." And I'm saying, "It's not VIPER, it's VIP." What is VIP? Exactly. I'll introduce you to some basic concepts and how VIP architecture works. VIP and VIPER, while having a very similar names, and they both have the basic components, which is view, interactor, and presenter, which is what VIP stands for, are different implementation of the Uncle Bob's clean architectural pattern. When VIPER creators were creating VIPER, they wanted to name it VIP at first, but they didn't want developers to read it as very important architecture, so they went with VIPER. Now, VIP architecture for writing clean Swift code was first introduced by Raymond Law. He created a website called cleanswift.com where you can read about how to use VIP pattern in UIKit. He created the pattern for UIKit to fix the messy view controller issue that we had at a time. He liked the concepts of VIPER but thought it to be a bit overcomplicated, and it didn't allow the use of segues as much as he wanted to use them, so he went with something different. If you look at his website, you can find a lot of good information and more detailed information about how to implement clean Swift VIP architecture, how to start. He's offering mentorship, he's offering books, has his own Slack channel or something. And he also offers, if you subscribe to his list, you can get some pretty neat templates that you can import into Xcode and start writing your iOS apps without worrying about the basic structure, which those templates do for you. I'm going to show you a demo of the small iOS app that I created for this purpose, and I'll show you how those templates look like. Those templates were created for UIKit, as is the whole architecture, and it hasn't been updated for 4 years now, so some of the code is a bit outdated, but you can still use VIP today, and I find it very useful working on a large project. Now let's start with VIPER, which you're mostly familiar with. This is the diagram of the concepts and their interconnections in VIPER. We have the view, interactor, and presenter as main components. The view talks to the presenter, presenter talks to interactor responds back, and then presenter responds back to the view, and we have the entity, which is our model, and we have the router. Now, VIP still has view, interactor, and presenter as its main components, but works quite differently. So let's remove the connections. Now, VIP pattern is unidirectional pattern, unlike VIPER. VIPER is a bidirectional pattern. Some of the known unidirectional patterns that you may have heard of are Redux, Flux, or MVI, Model View Intent. And these patterns focus on reactive UIs and state management. One property that all of them share is the interconnectivity between their components that aren't designed to mix, and every component has its own clear responsibility, which you'll see how VIP clearly implements that. Now, the cycle following the typical interaction in the mobile app goes something like this. It all starts with a view. User interacts with the view when they tap a button or enter a text in a text field, change the segmented control. Then the view creates a request object and sends it to the interactor. Now the request can be fetch the data from the network. The interactor, which handles the business logic of the app, takes this request object, performs some work like fetching data from the network. It can also interact with core data, deleting elements of the core data, adding to core data or whatever, and performs some work and sends the result as a response to the presenter. Then presenter handles the presentation logic. Presenter takes the response it got from the interactor, formats the data in the primitive types such as integers, strings, doubles, and sends the result back to view model as a view model to the view. Then finally, the view displays results to the user. And the cycle goes on and on for any work you're implementing. Request, response, and view model are three payloads that make the data model. Data models are decoupled data abstractions. Their responsibility is to pass the data between components, and they consist of only primitive types such as integers, strings, doubles. It's also important to mention that these components do not talk to each other directly. And it's one of the most important things about VIP architecture is the components talk between each other through protocols. And this makes each component of a scene less tightly tied to other components. The view asks the interactor to perform the business logic, but it doesn't know how the interactor is doing it. Now, there are more components than these basic components, so because interactor performs the business logic, sometimes you can have fetching the data from the network, which is you're doing some networking. Then you also can have doing something with core data, so database, and then that kind of breaks the single responsibility rule of the interactor, so you would want to add workers. Now, if you had fetching data from the network, you would add a network worker. So you would ask the interactor to fetch the data from the network, and then the interactor would add that responsibility to the network worker and call the network worker to fetch the data. And the network worker would send the result back to the interactor, and then the cycle goes on. Again, you could also have a core data worker, as many workers as you need to keep the interactor have less code and not have it all of the code inside. And then again, you also have the router. Now the difference between VIP and VIPER is that the view is one who talks to the router. If you click on a button or an item in a list inside a view controller, in UIKit case, that would call directly the router. If the router needs to pass some data to another view, it would get that data from the interactor. And I'm going to show that more in the demo example, which it will be much more clear rather than just looking at this theory. And then let's just go back quickly with the difference between VIP and VIPER. As you can see from the diagram, one of the most noticeable differences between VIP and VIPER is that in VIPER, presenter directs data between the view and the interactor. so the view and interactor don't talk with each other directly. This in turn can make presenter large, and it's hard to maintain this single responsibility. Sometimes you're not sure what goes inside presenter. Well, on the left side we have a VIP, and each component has a clear definition of its work. Every component talks to each other. Now, let's take a look at some code example that I created, a small iOS UIKit app that I implemented using a VIP architecture pattern. Alright, so this is the small app that I created to show you how to use VIP and implement it in a UIKit app. It's a simple application that's fetching the data from the Hogwarts API. You are presented with this selection. You select a house, say Gryffindor, and it gives you a list of all of the Hogwarts students that attended and were in the Gryffindor house from Harry Potter movies or books, if you haven't heard about Hogwarts. Slytherin would give you a list of Slytherin students, and then Hufflepuff, and then Ravenclaw. It's a simple app just to show you how VIP works. Now, as you can see, I'm using storyboards here mainly because when you import the templates, as I'm going to show you, it does suggest you to use storyboards. So I kind of wanted to implement it following those basic templates and not straying away too much from the basics. You can of course use programmatic UI or anything else you'd like. Now first, let's talk about the structure of your files in Xcode. In VIP, you would structure your files, you would put all of your features inside a domain folder like this, and then you would add a feature. So my first feature would be Hogwarts houses. So if you wanted to add a new feature, and in here we're mentioning in VIP, it's easy to add a new feature to your apps. So if you wanted to add a new feature, you would just add a new file inside this domain. This one is named Hogwarts Houses. Say you want to add another magic school. I don't know how they are named, but you want to present some other students from other schools. You can add the folder and then start adding your scenes and then all of the basic components. Now you keep your storyboards here. Then we have our model. So this is just our network model for the student, for the name of the student. Next you have scenes. Now scenes, most of the case, correspond to a single view in your iOS app. So we have a list of houses, which is not really a list, it's just those 4 buttons, and then we have a list of students. If you wanted to add more scenes and expand your Hogwarts houses domain, say you want to make it able for someone to tap on the student's name and then add okay, so let's say I want to add student list details page. When I click on the student's name on the list, it opens more detailed information about that student. Alright, so let's show you first those templates that I mentioned. So you add your templates using a new file, and then they are right here at the end. You see clean Swift, and you can add each component separately, or you can create a new scene. You would give a name to your scene. So because we're creating student list details, we would say student list details, and then it gives the name to all of those. You have a student list details view controller, interactive presenter, so on and so on. Create. Alright, and then it gives you all of these for free. As I already mentioned, these, as you can see right here, it's deprecated, so it hasn't been updated. The formatting is a little weird, but it works actually quite nicely, even though I do prefer adding these components myself. So it does give you all of these to use. Then you have a presenter, but it has functions like present something, and then you start changing one, you get a bunch of warnings, errors, so that's why I prefer adding them myself. But this is how you can simply add those components using the templates given by CleanSwift. And you can see here it says this file was generated by the CleanSwift Xcode templates. Alright, now let's take a look at the house list, which is the first view that we see when we open our app. So we have the house list view controller. As I already mentioned, these components work together, talk together by using protocols. So for the view controller, we have the display logic protocol. For the house list, we don't have any functions in here, so I just left it as an empty protocol here. And then you would conform to that display logic protocol, so you can implement functions defined in this protocol. As you can see, our view talks to interactors, so we have to create our interactor here, and also view talks to the router, so we also have this routing logic, and we have this data passing. Now data passing, as I already mentioned, is for the router to pass the data from another view to another view, and it's using the interactor for that, which I'll show in a moment. We have the button outlets. We also have to set up. Now this setup is already defined. If you use that template, you have to of course instantiate all of your interactor, presenter, and router and connect them with each other. This function comes from the template, so it does kind of suggest you to use UI storyboard segues. Simple logic, I connected all of the buttons to this function. Whichever house was tapped, interactor would the view would call the interactor and say get selected house. If Gryffindor button was tapped, it would send back Gryffindor, Slytherin for Slytherin, and everything else. And then once it gets that selected house, the view calls the router to route to student list. Now I'm using this function. I'm calling the interactor here, and I really don't have to call the interactor, but because router talk to interactor to get this data from, I'm calling the interactor. So if you can see in here, the router has this protocol, the interactor has this protocol called house list business logic, and it has a get selected house function. Now it has another protocol called house list data store. This data store is any data that needs to be passed to another view. So this is the house that we have to pass in order to get the student list for that specific house. And then we have our interactor, where we simply just conform to protocols and implement the functions. I'm just simply saying whatever house was selected inside the view, assign it to the house, and then the presenter does nothing here, because as I already mentioned, sometimes you're not going to have anything in here. I'm sending this data to the router, so I'm not sending, the view doesn't need anything returned from the interactor or presenter. That's why we have no presenter functions. And then we have the router, which implements this routing logic protocol that's called route to student list. It's using a segue, storyboard segue, Then we have another protocol which is called data passing. Now, data passing and data store protocols talk to each other. Data passing takes the data from the data store, which is implemented inside the interactor. So router and interactor talk to each other when there's any data to pass between the views. And in here, as you can see, router has a weak reference to our view controller. It also has a reference to the data store. And then in here we implement the route to student list. We pass the data to student list and navigate to student list. So the router's only work is to route and pass the data between the views. Then we have our models, but in here we have no models. Let's take a look at our student list. Now, our student list view controller fetches the data from the network, so it does implement the display student list method inside the view. This function is going to be called by the presenter, and this is the view model that our presenter needs to give us and pass to us, so we can display the data and put it inside this array of students. Okay, now the view calls the interactor. The interactor has fetch student list function. Now I've implemented, created a network worker that's only job is to fetch students from a URL and give that decoded data back to the interactor. When the interactor gets this data from the students, is going to create a response and then send that response to the presenter. So the presenter can then create a view model and display the data on the view. Now we have no routing in here because we're not routing from student list to anywhere, but if you wanted to create a student list details screen, you would create a router from student list to student details, and then you can implement your logic inside student list details. Now we do have models here, so let's take a look at them. Now they're implemented as enums. You would have an enum like so. At the moment, our app is only or our student list scene is only fetching student list, so it has an empty request because we're not requesting anything from you. We're just requesting some data, but we don't know what kind of data. And then the response is going to be our students array, and then the view model is also going to be our students array. But now if we wanted to implement more features, more business logic, we would add another enum called, so we are saying fetch student list, but we can have enum I don't know, show student last name or whatever, and then you would again implement a request, a response, and view model for this one, and then so on and so forth. You can add more. Now I haven't wrote any tests in here, for some basics ones, but you can see how easy it is to write tests for this pattern. You define your system under test. You would, for the view controller talks to the interactor, so you would create an interactor spy. I create inside this class. It conforms to all of your protocols defined, and then you implement this function. You can test whether this function gets called, whether the house is correct, or whatever you want. You only test your view logic, and then in the interactor you would only test your business logic and whether any function from the that needs to be sent to presenter is being called. Same thing for the presenter. You test your presentation logic, and so on and so forth. So this is just a brief overview of a small UIKit app that I created using VIP pattern. It's simple, but I hope you get the idea of how VIP works. I've been working on the project that uses VIP patterns for over a year now. It's a very large project for a large iOS app with 24 network calls and different features. I found it hard when I started. There were too many protocols. I didn't understand what goes where. But I wasn't familiar with VIPER at the time, which I think would have been helpful, at least knowing that one. But once I understood its concepts and how it's all interconnected, it started making a lot of sense. I found easy to understand its coherent logic separation. You knew what each component does once you get control of the basics. View presents the data on the view, interactor handles the business logic, presenter handles the presentation logic, and you would just call it in circle. Every component has a single responsibility. You also tend to write shorter functions for that reason. And it's much easier to write unit tests because you know what you're testing exactly. It's also easier to add new features. When you have a large project and then you want to add new scenes, new features, you just create a new scene folder. You can implement the VIP cycle, or you can import from the template. It's much easy to just start writing your code without overthinking how to add new code. You don't have to refactor anything. You just add components and connect them with the router if you need to. It does work well on larger projects. I think it adds unnecessary complexity into smaller projects. Now, even though most of the time you know what goes where, sometimes it's hard to maintain separation between you and presenter, and you're not really sure what should the view do or what should presenter do. And I've seen this a lot actually, presenter functions that do nothing because the view calls the interactor to give it back some data, but the data doesn't have to be formatted, or presenter doesn't have to do anything with the data. So the presenter will get the data from the interactor and just call the view function. And so in essence, it doesn't do anything. It does rely on protocol with complicated naming and responsibility, which is hard to understand if you're new to this architectural pattern, if you haven't worked with VIPER or you're a new iOS developer. But once you understand the basics and how it's all interconnected, it's actually easy to use and implement new features. And it does take time to onboard new developers. Now, does it work with SwiftUI? I implemented a small SwiftUI app that's using VIP pattern, and I found it doesn't really make sense to force use it with SwiftUI, especially because it's made for UIKit. I found complicated routing logic because SwiftUI will rely on navigation link, and in VIP just implement it differently. Even though you can use it and you can implement it, I just personally don't think I would create a SwiftUI project and implement VIP pattern. Again, choosing architecture for your apps or project should be a matter of what your team decides, and it doesn't have to be to follow strict rules of MVVM or whatever you decide. Choose what works for you, your team, and your project. It can be some version of VIP, VIPER, or whatever you choose. If you'd like to learn more about VIP clean architecture, you can visit cleanswift.com website. It has a very comprehensive guide on how to implement, how things work. You can even find how it evolved over time. There are people even now still asking if VIP is going to be imported for SwiftUI on the website. Anything you want to learn more, you can find there. If you've used VIP or you intend to use VIP, or just your general opinions, please send them to me. You can find me on Twitter at the Vrzan. Send me a message, send me a comment now. I'm interested in hearing your opinion. What do you think about it? Would you use it in your project? Have you used it in your project? How has that worked for you? Let me know. Thank you for listening to my talk. I hope you learned something new today, and have a wonderful day wherever you are. Thank you.